Welcome to another. My name is K. Jitmar. I'm from Mechanical Engineering. Today, my topic is about LMTD method for a double pipe heat exchanger. Introduction to double pipe heat exchangers. Double pipe heat exchangers are used for small to medium heat transfer applications. The consistent of inner pipe and outer pipe allowing fluids to flow in counterflow or parallel flow arrangements. Understanding the LMTD method is essential for designing and analyzing these heat exchangers effectively. Overview of heat exchanger types. Heat exchangers devices that transfer between two fluids without mixing them. Common types include shield and tube plate double pipe heat exchangers. Each type has specific applications based on capacity, temperature, and pressure requirements. Purpose of LMTD method. LMTD method. The LMTD long mean temperature difference method helps determine the heat exchanger thermal performance. It provides an accurate calculation of the heat transfer rate consisting temperature variations. This method is widely used for designing and analyzing heat exchangers with dependent heat transfer. Basic principles of heat transfer. Heat exchange occurs through conduction, convection, and sometimes radiation. The temperature difference between the hot and cold fluids drives heat transfer. Effective heat exchanger design maximize heat transfer while minimizing energy costs. Temperature profiles in double pipe exchangers. In a counterflow, double pipe fluid flow in opposite directions, creating a uniform temperature gradient. Temperature gradient in a parallel flow, fluids flow in the same direction, resulting in different temperature profile. The temperature profiles influence the calculation of the temperature difference used in the long mean temperature device. Heat exchange analysis LMTD method. Defining hot and cold streams. The hot fluid is moved at the higher temperature, transferring heat to the cold fluid. The cold fluid enters at the lowest temperature and exits at high temperature. Proper identification of streams is crucial for accurate heat transfer calculations. Assumptions of the LMTD method: the heat exchanger operates under steady heat conditions with no heat loss to surroundings. Heat transfer coefficients are constant along the length of the exchanger. The temperature difference between the hot and cold fluids varies along the length but can be represented by low algorithm mean. Calculating temperature differences. The temperature difference at the inlet is delta. The temperature difference at the outlet is delta. These differences are used to compute the log mean temperature difference LMTD. Logarithm mean temperature difference LMTD formula. The LMTD calculated using the text LMTD equal to fractional delta T1 minus delta T2 in left fraction to delta T1 into delta T2 right. It accounts for varying temperature difference along the length of the heat exchanger. The LMTD provides an effective average temperature difference for heat transfer calculations. Heat transfer rate calculation. The heat transfer rate calculated is U times A time LMTD, where U is the overall heat transfer coefficient and is the heat transfer area. This relation helps determine the needed surface area or access performance. Application of the LMTD method is double pipe exchanges. For double pipe exchanges, the LMTD method considers the flow arrangement counterflow of a parallel flow. The basic temperature differences are determined based on inlet and outlet temperatures. This method simplifies complex temperature profiles into an average difference per calculation. Step-by-step calculation procedure: identify inlet and outlet temperatures of hot and cold streams. Excuse me. Calculate temperature differences delta 1 and delta T2. Compute the LMTD using the formula and then determine the heat transfer rate. Correcting for heat exchanger configuration for for counterflow configurations and LMTD formula applies directly for a parallel flow. The same approach is used, but the temperature differences are different. For mixed or cross flow arrangements, correction factors may be necessary. Limitations of the LMTD method. The methods assume constant heat transfer coefficients, which may not be true in patients. It is less accurate when temperature differences are very small or very large. For very complex or highly variable conditions or other methods like the effectiveness NQ may be preferred. Advantages of using LMTD method provides a straightforward way to analyze and design heat exchangers, account for temperature variations along the length of the exchanger, widely accepted and used in industry thermal performance evaluation. To the weight exchanger and heat exchanger to the analyze and design for account for the temperature variation along the length of the exchanger, widely accepted used in the industry for thermal performance. Practical example: counterflow double pipe. Given inlet and outlet temperature, calculate delta T1 and delta T2. Compute the LMTD based on these temperature differences, determine the heat transfer and rate and using calculated LMTD. Example: double by physics. Water at a temperature of 175 mass flow rate is used to heat ethylene glycol. The cold ethylene glycol is available at 90 degrees with a flow rate of 30,000 lbm per hour. A double pipe could not counterflow heat exchanger consisting of 1% standard by 2 heat standard, and the exchanger consists of two heat pin exchangers. Each the configuration is such that refined travels in series through determine the heat transfer, the outlet temperature of both fluids and pressure losses. Summary of key points. The LMTD methods complex temperature profiles into an average differences. It is essential for designing effective double pipe heat exchangers. Proper applications require accurate temperature measurements and assumptions. To the where and profiles into an average differences to the efficient double pipe heat exchangers to the temperature measurements and the temperature heat exchangers to various of the temperature and an average difference to the main thing. The LMTD method is a powerful tool for analyzing double pipe heat exchangers. It helps the optimizing performance and ensure the heat exchanger meets the design criteria. Combining the LMTD method with other analysis techniques can improve accuracy. References. Thank you.